Absolutely essential to getting big fast for Amazon was convincing customers to trust it with some of their most valuable personal information, their credit card numbers. And to understand how Amazon did that, we need to delve in to the age-old science of encryption. Powerful methods of scrambling messages mathematically had been developed long ago and employed most famously during World War II. But it was clear that something much more sophisticated was needed for the new digital age. The old method needed an upgrade because there was a fatal flaw. To explain this flaw, let's use a low-tech analogy, using padlocks instead of mathematical encryption. First, imagine two people, and one wants to send a confidential message to the other. Just like a customer wanting to send her credit card to Amazon. Person one, the sender, puts her message in a box, locks it, and sends it off. But here's the snag. The sender of the message now also has to somehow let the recipient know the lock's combination, the code to unlock the padlock. This step is fraught with problems. This is when thieves could surreptitiously observe the code, steal it, and open up the box. Of course, if our sender and receiver already know each other, they could arrange to meet in secret before the message is sent and share the code.
Unfortunately, of course, this mechanism is not of that much use in the context of online commerce. And the reason is, in online commerce, you want to enable confidential communication between pairs of parties who have no, right? It's simply untenable for Amazon to have gone into a private room with every possible future customer of Amazon. So we needed a different plan.
And that plan came from a trio of California-based mathematicians named Whitfield Diffie, Martin Hellman, and Ralph Merkle, who developed something called public key cryptography. Their scheme turned how encryption had been done for centuries on its head. Let's use our low-tech analogy again to explain the essential idea, which is brilliant, but kinda subtle. The sender puts a message in a box like before, but this time, instead of locking it with her own padlock, she asks the person who will receive the message to buy a padlock and send it to her. When the sender gets the padlock, she uses it to lock the box, and then sends it. Now if someone intercepts the box, they can't open it. In fact, even the sender can't open the box once it's locked. The only person who can open it is the intended recipient, the only person who has the code. Thus, presto, you have something close to perfect security. It took several years and some very clever math to create internet-friendly digital versions of the padlocks and boxes used in our analogy. But work it does, and public key cryptography is the linchpin of secure e-commerce.
The public key is used for encrypting, that is, rendering secret the data that the sender wishes to send confidentially to the receiver. Okay. There's also what's known as the private key, which is the combination used by the receiver in order to take the encrypted data, decrypt them, and produce the original message.